We have two objectives. We're going to use properties to simplify and evaluate log expressions, and we'll learn the change of base formula to convert a log to any other base. So first of all, I want to remind you of the properties of exponents because logs are inverses of exponents, so the properties of logs are linked closely to the properties of exponents. So if you remember when you multiply powers, as our first example, you add the exponents to simplify. And when you divide powers, you subtract the exponents to simplify. And the last one is when you raise a power to a power, you multiply the exponents. So when we look at the properties of logs, keep in mind that the answer to a log function is an exponent. So our first example, or our first property, is when we are taking the log of a product, we can expand that by taking the sum of two logs. So again, remember that those are the exponents. We're adding the exponents, and it originally came from multiplying. When we're taking the log of a quotient, we can expand that by subtracting the logs or subtracting the exponents. And then finally, when we take the log of a power, we can expand that by multiplying the log by the power. So again, you've got two powers on that last one. Log base a of x is an exponent, and y is an exponent. So let's see how these work. We're going to condense each of the expressions and then evaluate. These properties of logs are especially helpful in cases like these where when you look at the log individually, you can't evaluate it nicely. So for example, log of 40, 10 to what power gives us 40? It's not a nice number. And same with the log of 25. So when we're adding two logs, we can condense that using multiplication. So we have log of 40 times 25, and 40 times 25 is 1,000. So now we can evaluate that. 10 to what power is 1,000? And it would be 10 to the third power, so the answer is 3. Our second log, we have a coefficient in front of it. So this, remember, we just kind of flip it to the back, and it becomes the exponent on our 8. So this is log base 4 of 8 squared. 8 squared gives us 64. And 4 to what power gives us 64? The answer would be 3 again. And our last one, we have log base 3 halves of 12 minus log base 3 halves of 18. So again, looking at these logs individually, 3 halves to what power gives us 12? We can't evaluate that. So when we have subtraction of logs, we can condense that using division. So it becomes log base 3 halves of 12 eighteenths. I'm going to simplify that 12 eighteenths to 2/3. And what I notice is that 2/3 is the reciprocal of 3 halves. So 3 halves to the -1 power will flip it to give us 2/3. All right, now we're going to take a look at using the fact that exponents and logs are inverses of one another to simplify some expressions. So my first expression, my exponential is base 2, and my log is base 2. So 2 to the power of log base 2 will cancel each other out, leaving us with 12. Similarly on B, log base 5 of an exponential with base 5 will cancel each other out, leaving us with x divided by 3. And the last piece we're going to learn is the change of base formula. So if we start with a log base A, we can change it to any other base that we want to by dividing what we're taking the log of by the base of the original log. And the way that I kind of keep this straight when I use the change of base formula is that when you look at this original log question, you see the base as being lower than what you're taking the log of. So the lower piece goes in the denominator, and the piece that's higher than that, it's not the subscript, goes in the numerator. It stays above the base. So let's take a look at two examples of how to use the change of base formula. So where the change of base formula is extremely helpful is changing it to a common log so that we can punch it in on our calculators. So again, remember, the 30 is higher than the 4. So we'll have log of 30 in the numerator. And then the 4 is lower, so we'll have log of 4 in the denominator. So log of 30 divided by log of 4 gives us about 2.453. Similarly on B, again the 14 is higher, so the log of 14 goes in the numerator. 2 is lower, so the log of 2 goes in the denominator. And evaluating log of 14 divided by log of 2, we get about 3.807.